So next time when you're taking a bus in your city, try that, or going by public transport, try that. Right? It might be there in Delhi. I don't travel that often to Delhi, so I don't know. Since looks like most of you are from from that area. Data, right? Others are specific to a smaller region, like data from local municipality or an NGO or a housing developer. In fact, I'm not sure if you are aware, you can also register yourself as a volunteer to collect data for Google. If you go to the Google website, you can do that. Then what happens is Google does some stringent data vetting process, and you cannot give them any information, right? They need to validate it as well, right? So they have a team which does that. New tools available for government to upload data. They said, okay, we'll make it easier for you to upload the data. All you need to do is use my tool to update that. That is what. So that is about the data. Imagery, data. What is the third point? Human factor. Right. Imagery and data are no doubt the key components of map making, but they are static and cannot keep up the pace of the ever-changing world. Here comes the third important facet of Google Map: the people that help tie everything together. Right. I'm over here on point B, just in case if you're lost. Google had data operations teams staffed all across the world that plays a role in just about everything, right? It's about every aspect of map making, from gathering street view images and vetting authoritative data sources to correcting the map for inaccuracies and training machine learning, right? It's an extensive case study. Read it later on, guys, when you have time. Google also has a community of local guides and Google Map users. Like exactly the thing that I was saying, you can volunteer yourself, right? Who are empowered to correct the map via the send feedback button in Google Maps, right? Google team reviews the information and publishes if it has high degree of confidence that it matches the road, business, and addresses, right? So there's a vetting team which you upload the information, vetting team will vet it and they'll let you know whether it's right or wrong information, right? The human factor. So Google cannot do it without a team of people who are going to help them out, right? The fourth point: machine learning use, right? Machine learning usage. Now, how does Google use machine learning? Right, I'll give you an example. To increase the speed of mapping, Google turns to machine learning. Right, machine learning allows the team to automate mapping processes while maintaining high level of accuracy. How is that? For example, previously an algorithm that tried to guess whether a part of image was a building or not, resulting in what we dubbed as clear and unfuzzy image. Suppose they've taken something like this, right? Fuzzy image. They look at it and they say maybe things are not very clear. What they will do is, to fix this, Google worked with data operations team to trace common building outlines manually. Go there and outline them, right? So maybe if in an area there are like 50 buildings, they'll go and outline, make a sketch of maybe 5 buildings or 10 buildings, right? Feed this information into a machine learning algorithm, and then machine learning algorithm is going to give a better picture. Image corresponds with the building edges, which basically gives you a better picture. So here is what it was for Google without machine learning. Fuzzy images, they did this. I'm going to come back to that, and they came up with this much more clearer picture, right? Without getting too much into details, if you know a little bit about machine learning, this is the machine learning process, right? Don't get too overwhelmed by this. You have historical data. Basically, it's in two parts. You do something with the historical data, you do something with the real-time data. With historical data, you build model for prediction. With real-time data, you feed the real-time data into your model and you get predictions. That's simple. I'll repeat a little slowly. With historical data, you build a model, right, for prediction. This is a particular area, what it looks like. The clearer one might look like a little better. So feed that information, you'll get everything clear. So build a model for prediction and use that with the live data to get your predictions. And that's what machine learning in gist is all about. Right? So you can read books, forever on that, but in gist, this is what machine learning is all. Yeah. So I was here, right? That's how. So Google Maps is basically a product of these 4 parts: imagery, data, collecting images from the satellites, capturing data and analyzing it, the team to do it, the human factor, and the machine learning model usage of machine learning model to further improve your predictions. Right. This is a very interesting case study, my dear friends. If you really want to get to read it, click on this link. I would suggest click on this link and read the entire. It will help you understand how big data can really be useful. And again, relating to something that we use in our day-to-day life. Your what do you call your Google Maps. I use it day in and out. I hope you also do the same. I'll just give you another few minutes to just digest all this. I think I'm done with most of the case studies. I think I'll tell you about Waymo also. Google Waymo. I think in today's session we'll touch a little bit about formally what big data is. Tomorrow we'll dive deeper But I suggest you guys go through the recording, you guys go through the the details that I'm telling you to do, so that it becomes easier for you to catch up tomorrow. Yeah. Okay, let's go ahead and do this. The Google Vimo project. And again, I'm going to play a video. I'm sure you would have heard about Vimo. Why don't I go ahead and play this video right now? Very nice. Whenever I play this video, I actually feel very good about it. It's actually a very, very good video. Vimo is actually live in US already. I think some of the cities in US it is already live. In sense, people are using it. So yes, let me just go ahead and tell you what it has said in the presentation right now. I just went ahead and jotted down everything in this slide. What does it do? It does the light detection, first of all. Light detection and ranging. Using sensors such as radars, camera, etc., the vehicles are able to create a short distance understanding of its surrounding in real time. You would have seen in the video, when the cycle was coming, or what all cars are, are parked. It nicely dodges them, right? And you can see that, it said in the video that it can do that for three to the distance as long as 3 football fields. So that longer distance, right? So that is one thing it does. Second is mapping. Right? What kind of mapping? The vehicle's computer must possess and have the ability to process highly detailed, comprehensive map of street features, including street light, signs, road, and curve. Right. So mapping the road and understanding which lane is going where. The third is the vehicle-to-vehicle communication, made possible as cars are fitted with computers having internet. Yeah, the cars are having internet wherein cars can communicate with each other to find out those distances, where what vehicle is, right? And last but not the least, sense, plan, and act. Now, to plan and act in a timely fashion, the vehicle's machine learning algorithm must be able to predict the outcome based on high volume of data. It does exactly that to wait pass through the different type of scenario. So it looks at a scenario, it takes that into account, feeds that into a machine learning algorithm. With the help of that machine learning algorithm, it says, oh, you know what, I have to take a left turn or a right turn or stop or go ahead in the most safest manner. Right. So I think the other sense that you might get from whatever I am presenting right now is that the big data world, the big data part, is something that is related to machine learning. In fact, I should say the other way around. The machine learning world is also related to big data. Big data stores the data, you analyze it. Machine learning predicts. It's actually very, very simple, right? In big data, you save the data and analyze it. In machine learning, you predict, right? As Mr. Vinod is asking, can you please repeat Waymo, right? It's very, very simple, Mr. Vinod. You can read what I have written in the slide. It's very, very simple. The use of data to automate your car and make them driverless. That is what Waymo is. The car can be driven without driver. You see what I'm saying, Mr. Vinod? Yeah. So
Yeah,
the concept of the driverless car. And also there is, all these slides, Mr. Vinod, have links also. So if you've missed anything, just click on the link. Like for example, this slide has got this link over here. Just click on it and the video will start. Just go through the video. All right. Okay. Okay. How much is the time we have? We have about, we have some time. I can, where we are right now. Let me just take a, okay. So one last example and then we'll move on, right? And that example is about, from, very interesting movie industries, right? Big data is used in the world of movies also nowadays. And that comes as a surprise. I'm not sure if that is going to come as a surprise to you or not, but it definitely came as a surprise to me when I read about it. There's a company, and I read this in the Hindu, Woodcutter Films. There's this company called as Woodcutter Films. They are based in Hyderabad and Bangalore. So what do they do? Interesting people, huh? They are from IIT Madras and all that. I'm just going to read it out and give you more background as as we read this more. They're based on the idea of unpredictable nature of outcomes for movies in terms of success or failures, right? It's very unpredictable, right? Any movies can bomb, right? Any movie in the world can become a hit, and any movie in the world can bomb. So how would you make out whether a particular movie is going to be a hit or a flop, or how can you make sure that you put maximum effort to make that movie a hit, because there's $1 million investment that has been done in it, right? So here also the same thing happens. I'm reading point B over here. The CEO of the company himself suffered a failure with one of his movies with Dhanush. I'm sure you would know who Dhanush, the South Indian star. His movie, although critically acclaimed, bombed at box office in terms of revenues. Right. Armed with technical background, the CEO of Woodcutter Technologies set up a team in Hyderabad with 5 data scientists from IIT Madras to amalgamate, to mix his creative and technical talent with data analytical skills of his team. They started with a project of descriptive analytics on this movie called as Scooter Returns in 2017. Promotions from Excel Entertainment. So they took promotions, okay? And what they did was the team, I'm on point E over here. The team analyzed the audience reaction, right? They had, for the trailer, they just put some people in the, in the room, sample people in the room from the teaser of the movie and made relevant suggestion to Excel Entertainment on what kind of actors and dialogue to highlight in the trailer. So they, analyze the, with the help of cameras, mimic detection and all, they analyze the expressions which are coming on people's faces, right? And said, okay, this is the part of the trailer. This is the part of the trailer where audience were looking most interested or happiest or feeling good about it. Continue on with it. This is the part where they were looking not that interested, that invested. Remove it. Those kind of things. And they retrofitted the trailer. They said, okay, this is the part which are not working. Let's go ahead and remove them, and which is the part where working. Let us put more of that in the trailer. What happened is the movie. I'm on point F over here. The movie scored 76% on Book My Show, 65%, 6.5 on IMDb, and 92% like the movie on Google, right? So with that, they got encouraged, and that's the reason I've written humble beginning, right? They said, okay, now there looks like a scope, like some scope in this work. Let's do one thing. Let's build a model, maybe a machine learning model based on the data that we have, using box office numbers and data from movie distribution from all across the globe. Yeah, data is available. The crazy amount of data is available for free for you to analyze, right? I'll share many links with you from where you can download the data and analyze yourself. You go to Kaggle website, you can download so much data from there and use it. Now they made it this model, and the model identified unsuccessful patterns in the script, casting to predict success for probability. They said, okay, this is the model. This will tell you whether with these many variables, this movie is going to be, or trailer is going to be successful or not successful. The model identified, yeah, they combine it with another AI-based computer vision model that that captures emotions of the characters of the, right. The company's success prediction with accuracy rate is in the next slide. Here is the link which wherein you can read more about it. I went on the net and actually found the link for it, and I have put that for you all over here. This is their success rate. You'll be able to see how much accuracy, with how much accuracy they have been able to predict the success or failure of the movie. Savisanchi, Amar Akbar, and the new one, not the Amitabh Bachchan one. Taxiwala 2018, Antriksham 92%, and some other, like mostly I think it looks like South Indian movie. But imagine people like Karan Johar and all are not very far away from these kind of people, right? Because they are investing $1 million into into these movies. So why would they not go ahead and get something which is a little more predictable about?